Less than 5% of the world's astronomers changed the solar system forever. Inside a conference hall in Prague, exhausted scientists sat beneath a projection screen, while bright yellow voting cards lifted into the air. Minutes later, Pluto was gone. Not physically. Nothing in the sky had changed. But humanity had just been told that one of the most familiar objects in existence was no longer a planet. And the part that made this dangerous was not Pluto. It was the process. Because what happened in that room exposed something far more unsettling. Scientific reality is not always shaped by discovery alone. Sometimes, reality gets rewritten because time runs out. The crisis had actually started months earlier, nearly 6 billion miles from Earth. For decades, the solar system looked stable. 9 planets. Every textbook agreed. Every classroom repeated the same sequence. Mercury through Pluto. The system felt permanent. Then, astronomers found something they did not expect. A massive object beyond Pluto. Its name was Eris. And Eris created a problem nobody had prepared for. It was roughly the same size as Pluto. Some measurements even suggested it might be larger, which meant astronomers now had only 2 choices. Either Eris became the 10th planet, or Pluto stopped being one. But that was only the visible problem. The deeper issue was worse. Scientists suddenly realized they had spent generations teaching humanity a classification system that had one fatal flaw. Nobody had ever properly defined what a planet actually was. The word existed. The science did not. And the countdown had already started. Because Eris was not alone. New telescopes were now detecting more large icy bodies in the outer solar system. Sedna, Quasar, Haumea, Makemake. The list kept growing. Every new discovery threatened to break the entire planetary system apart. If Pluto stayed a planet, dozens of similar objects could follow. The solar system might eventually contain 50 planets, possibly more. Educational systems would have to change. Scientific catalogs would become unstable. Classification itself was beginning to collapse. And the International Astronomical Union, the organization responsible for astronomical naming standards, had one shrinking window to stop it. In August of 2006, hundreds of astronomers gathered in Prague. The assignment was simple. Define the word planet. Officially. Universally. Permanently. But almost immediately, the process began breaking apart. Early proposals created chaos. One draft suggested Pluto would remain a planet. Even Earth's moon might technically qualify under some interpretations. Scientists argued constantly. Meetings stretched late into the night. Committees rewrote definitions over and over. And each revision created new contradictions. Time kept disappearing. Because the conference was ending, and if no decision happened now, the classification crisis would continue spreading. The yellow voting cards were waiting. But first came the temporary solution. A working definition finally emerged. A planet had to orbit the sun. A planet needed enough mass for gravity to pull it into a nearly round shape. And then came the final requirement. A planet must clear its orbital neighborhood. That last phrase changed everything. Because Pluto failed immediately, Pluto shares its orbital zone with countless icy Kuiper Belt objects. It never dominated its region the way Earth, Jupiter, or Neptune do. By the new definition, Pluto was disqualified. The problem seemed solved. Until the room started emptying. Here is where the story becomes larger than Pluto itself. The final vote was scheduled on the last day of the conference. But by then, most delegates had already left Prague. Flights were booked. Schedules were ending. Scientists returned home. And when the defining vote finally arrived, only around 400 participants remained inside the hall. The global astronomical community numbered roughly 10,000 professionals, meaning fewer than 5% of the world's astronomers were about to redefine the solar system for everyone else. And there was no delaying it. The countdown had reached 0. The yellow cards went up, one by one, quietly. Almost mechanically. The giant projection screen displayed the result. Pluto had been removed. 9 planets became 8. Not because Pluto changed, because procedure changed. But then the safest version of the story began falling apart. Public reaction was immediate. Schools resisted rewriting educational materials. Scientists openly criticized the vote. Some argued the process was rushed. Others argued the definition itself was flawed. Planetary scientist Alan Stern, later leading New Horizons, publicly rejected the classification entirely. The scientific consensus everyone assumed existed had never actually formed. Instead, procedural mechanics had forced a conclusion before agreement existed. And suddenly, trust itself became unstable. Because millions of people had believed scientific definitions worked one way: observe reality, collect evidence, reach objective truth. But Prague revealed another layer. Sometimes institutions face operational pressure. Sometimes classification systems begin collapsing faster than consensus can form. And when deadlines close in, decisions happen anyway. Return to that conference hall. Exhausted scientists. Bright yellow cards rising into the air. A silent projection screen removing Pluto from the list humanity had trusted for generations. The image looks simple. A routine scientific vote. But it was never really about Pluto. That room revealed something much bigger. Reality itself can become procedural. Not discovered. Declared. Sometimes the universe does not change. The paperwork does.